Greetings, Dr. H. This is my Excel workbook. Well, I will be talking about my 6 scenarios and explaining what I've learned thus far. I am going to share my Excel. Okay, so first we're talking about our relative and number density. Here we're talking about scientific notation. Scientific notation is pretty much simplifying large numbers. So we got 3 objects here, Japanese spider crab and 2 states. Here on the right, you can see that I put it in standard notation, and on the left, we have scientific notation. So for an example of California, this is the standard notation here, and as you can see, it has a lot of zeros. So what the scientific notation is doing is eliminating those zeros. So we would write it as 1.20 to the sixth power, and that e plus is showing that it's positive. E minor can show up as well if the number is a negative, and what that is saying is that the number is smaller than 1. We talk about body movements here as well. Here we got body movements of all of these objects here. We have a solar system that had 2 numbers, which I had to find the average about, as well as the local group. And we had a total of 7,506,537 total speed. We created a pie chart, and we created a bar chart here. Our pie chart is showing the percentages. You can see local group has most of the percentage, 61%, and the bar chart is showing the speed here at the vertical, and then horizontal is showing the bodies. And I set up data labels so you can see the speeds that they are moving. Okay, we're talking on scenario 2. We're talking about misleading data. We're talking about very bias and false reports. So 3 causes of bad data is sampling bias, question flaws, and interview effect. Those things can make small differences look like they are very large. So here we have an example. We have presidents and unemployment rate. 5.21% and 5.19%. Here they made a chart and they set up the vertical axis to start at 5.18, and you can see a big major difference. But if we fix that and we put the vertical axis at 0%, you can see that there's no much difference. All right, so if we find the difference here with this cell, you can see that the difference is 0.02%. This is the same example here. They started the vertical axis at 105 scores, 105, but it's supposed to be starting at 0. And when you fix that problem, you can see that the differences are not that big. And I put data labels right here on top of the chart so you can have a better view of them. We're talking here about contributors and how much they contributed in dollars for an arena funding. So here they made a pie chart, and they made they said that the city contributed 265 million, and they saying that they did half of the contribution. But as you can see on this pie chart, that is incorrect. The city contributed actually 65% of that. And you can see the major difference here when you put a correct data and when it's wrong data. Okay, so here we're talking about companies, and we're talking percentage of sales. What's happening here is that they made a pie chart here, and they put Cartera here in the center, saying that their sales was 4.5%. When we made our pie chart, we can see that Cartera had, not that big of area here. We have 4% for Cartera. So what we did was we measured these circles to see the actual area of this circle right here. So I made a little chart saying circles, the inner donut hole, which is the small one, and the outer, which is the big one. We found that it was a diameter of 1 for the small one, and if I move it, you can see that it's right about there. So the diameter of 1, and the formula to find the area of a circle is pi times diameter divided by 2 to the square root of 2. So if I click on the cell, you see I made the formula there, and what we did was we divided those 2 formulas, and we came up with a total of 13.7%. So what these guys really here are showing is 13.7%. But it's supposed to be 4.5%. For scenario 3, we're talking about probabilities and populations of having these 3 risk factors, which is obesity, type 2 diabetes, and high blood pressure. So we know that there's 329 million American population. So how do we find the percentage? How do we find that 29% of those people are obese? So what we did was we we multiplied 29% times 329, which is the population of Americans. Click on the cells, you can see there the formula. And then as we keep scrolling down, here it gets tricky because this is type 2 diabetes and obese. So 90% of Americans have type 2 diabetes and are classified as obese. So that's just a little bit of difference. What we did, we multiplied the 90% times the type 2 diabetes. On the bottom, we have all three. And then on this other Venn section, number of Americans in Venn sections, what we did was, it says here, obese and high blood pressure minus type 2 diabetes, obese and high blood pressure. So what we did was we got this number right here, obese and high blood pressure, 82.2, and we subtracted by all three because it's overlapping data. To find out how many Americans have without of these risk factors, health factors, I'm sorry, what we did was we found the sum. We got the sum of 329.7 million, and then we subtracted by the sum of all of these numbers, and we came up with a total of 208 million. And then to find the percentages in the sections, what we did was we got the number of Americans without any of these risk factors, and we divided by the Americans in millions, the total American millions. And then we made a Venn diagram. We made a Venn diagram here. We got two Venn diagrams. We got the number of Americans in millions and then Americans in percentages. So there's 4 sections on these Venn diagrams. 2 of these are differences, you can see right here, and 1 similarity, and then we got the universal. So if we compare these, we are looking at obese 10.3 million, and in percentages we're looking at 3.1 million. I mean, sorry, 3.1%. The number that have all 3 is 28 million, and then 8.5%. We also look at percentages and highest probability depending on where you live. So here I have a chart. I snipped the chart of high risk factors percentages depending on where you live. So these purple ones show that here high obesity is in a high percent. So if you have obesity, you have a higher percent probability to have type 2 diabetes and high blood pressure. So chances are that if you are living in one of these states, you might be in risk of having type 2 diabetes, high blood pressure, or being obese. For measures of center and distribution, so I'm going to go in ahead and describe the range here. The range, median, mean, standard deviation, and coefficient variation. So the range is the difference between the lowest and higher value. The median is our center of the data, and our mean is our average. Standard deviation is our average difference, and coefficient variation is our measure. It measures a more precise spread of data. Here we got, I'm sorry, I made a mistake. This is a Q1, and what Q1 is doing, it is the center of our lower data entry, and this is Q3. And how we did that was we pretty much summed both of these numbers, and then we divided by 2 to find out the average. Our median here is our 19.8, and we inserted a chart in our we inserted box and whiskers as well. Our middle line is our median. Our lowest data entry is our lowest line, right here in the lowest line, and our upper data entry is our upper line. We also set up a standard deviation bell curve that shows what's the standard deviation from the mean to the first line here, as you can see. So what this pretty much is showing is that out of Army recruits BMIs, 68.2% of those recruits have BMI scores between 16.7 and 23.6. So 16.7 and 23.6. Something that I forgot to mention as well was an outlier here that we have at the random mall shoppers. So an outlier is very different from the other data that causes a skewed data. So you would not be able to use the mean in this chart right here. Scenario 5, investments and sales and profit. So here we got basic sales and profit. We have a formula of 500, which means that each flamethrower costs $500. So 20 sales, we made $10,000. And as you can see, our profit is going up based on our sales. But then here we I'm sorry, I forgot to click on the cell so you can see the formula. Here as well, as you can see, we set up another formula because we are adding the investment of $1,200. So if you click on the cell, you can see that I made the formula, and this is pretty much starting you out at even. Then at 100 cells, you hit bottom dollar, and at 200 we broke even, and at 300 cells we max profit. So I made a little chart, and you can see where those um, cells are hitting. I also made a little chart showing the simple and the annual compound and continuous compound. If you click on each of these, you can see that I made the formula here on top. You can see that the formulas are up here, and you can see that the simple interest is gonna save you the most money. Annually compound is gonna add up, and then continuous compound is gonna have gradually increase as well. So as you can see on the first year, it's not much of a difference, but if you're looking at our years, if you keep going down, scrolling down to 11 years, you can see the major difference here. And then on the chart, you can see that our blue line right here is our simple interest. Our second orange line is our annual compound, and then third is our continuous compound. And you can see how these compound interest rates are moving up. So depending, I mean, if you are investing or like you have a car loan, you don't want any compound interest. Our 5-year financial plan we're talking about here is I got a job, I got a career, and I'm thinking about the future. But most importantly, I'm thinking about cost of living, where I'm gonna live. How is that gonna affect me? Because some places are more expensive than others. Comparing California and Texas, you know, they have state taxes there, and the mortgage for a home would be way higher. So the average pay for a border patrol agent, which would be my career, would be $97,000, and I divide that by 12. Okay, because I'm doing a monthly income, so the salary would be 8,000 plus my disability. I would be getting a total of $2,241. So then I searched up and the tax rate that I'd be paying. I searched up the truck that I want, the cost, the mortgage of a home that I would like, and then I did all these expenses here. Then I totaled them. As you can see, I did a total of $4,801. Um, so with my monthly income, it's 9,241, and then my monthly expensive, I am gonna have a difference of $4,439. So what I'm gonna do with those $4,439, I'm gonna set it up here to my savings and investments. I made a pie chart and a bar chart too, and I showed data labels here so you can see the amount and what expenses I'm doing, as well as I did a little time management here to set up my hours of sleep, work, eating, gym, family, and I totaled them of 24 hours because there's 24 hours in a day. Nutrition per week, 4 meals a day, and these are the different categories here that I have: my dairy, vegetable, fruits, grains and proteins, and I set up that pie chart too to show those data labels. Most importantly here is to know the cost of living where you're going, because maybe your career can't support the wages and you might be broke someday. Um, what's very important as well is to know how to manage your time well, nutrition, and have budget, because that's very important in stress. And so far, that's it for my 6 scenarios. I hope it wasn't too late. I know that it was a little late because I had problems, but I will really looking forward for your feedback, Dr. H, and I hope you have a great day. Thank you.